everyone. Sorry for the bit of a technical snafu earlier. This is welcome to joining us at the weekly Taraxa AMA. My name is Stephen, co-founder of Taraxa, and today we're going to be doing a co-hosting. So with Justin, please say hi.
Hey guys.
Yeah, so Justin is my co-founder, my college classmate and CTO of Taraxa. So today, as usual, before we start with getting into the Q&A from our attendees, we're going to just pick a small topic that we've been reading about or we've been thinking about, or it's somehow on the top of our heads. So today we're going to talk a little bit about this interesting proposal within the Ethereum ecosystem, the EIP 1599, which is about
1559. Yeah.
Oh, 1559. Oh, that's right. 1559. That's right. 1559, which is trying to address the or trying to actually improve the way that Ethereum handles fees. So Justin has read into this in much more detail than I have. So can you start us off, Justin? What is EIP 1559 and what kinds of problems is it trying to address?
Yeah, so the Ethereum Improvement Proposal, which is what EIP stands for, is 1559 is to try to address the pernicious problem of deciding what to pay as a gas fee when proposing a transaction within the Ethereum network. And fundamentally, one of the problems that Ethereum has, like compared to other blockchains such as Taraxa, is that it's very bottlenecked in the number of transactions that it can handle. And of course, as an established chain, it's very much in demand to have transactions. So it doesn't solve that problem, but it tries to address the problem of, given that there is a very big demand, people don't know what to use as their gas price. And by having their current system as a first price auction, so you say, okay, I'm willing to pay this much, right? And other people put in a bid, and the winners are the people that are willing to pay the most. And that's a very simple solution, but it creates a very big problem on the consumer side, i.e. the person who's trying to generate transactions and go about their business and figuring out what price to use. So EIP 1559 has a model in which you try to generate sort of a baseline gas price fee that everyone would pay to put in their transaction, plus an additional tip that people are willing to pay in cases in which you still have like high demand and you're trying to cut the line and whatnot. And by having that sort of base price be calculated by the consensus mechanism, be calculated by the network rather than just pulled out of a hat by the users, you try to get sort of a stabilized base price that people pay in periods of predictable demand. And so that looks much better to the consumer, because then I know, okay, hey, today transactions just like yesterday cost the same amount of money as they usually do, and I don't have to like go to a website and look up what should I put in right now in order to get my transaction in. I can just put in that sort of standard amount that is the going rate. And we can of course get into the details of how it does that.
Right. So I mean, it sounds like the primary problem that this proposal is trying to resolve, it's not really trying to decrease the total amount of fees that we're trying to that are being paid right now on the Ethereum network, but really try to improve the predictability through which applications figure out how much fee each transaction needs to pay for, right?
Yeah, I mean that's right. All of this, to the extent that it's governed by economics, should be governed by supply and demand, right? So if you're not really changing the supply and demand, then given that Ethereum has a very limited supply compared to like Taraxa, the demand, and the demand being high, you would expect the price definitely to be high. So that's not changing. But what it is changing is introducing a mechanism in which you can sort of stably arrive at a supply and demand curve, and therefore get a stable price, as opposed to sort of just the clamor of people trying to always cut the line and no one really knowing what the actual stable price ought to be.
Okay. So that's kind of interesting. So fundamentally, it seems like having an extremely high fee is really an architectural or scalability problem, right? It's not really something that can be solved with a new economic mechanism. So this is really just a stability, a predictability, improvement. I can you talk a little bit about how it's trying to figure out whether or not there's more or less demand in the network? Like, how does it do that? Like, do the nodes just come around and ask each other, like, how many transactions do you have, like, backed up in your queue, or like how is that really done?
Yeah, so it creates a proxy for demand, which is how big the blocks that are being produced are. So the first change is it introduces a variable block size as opposed to a fixed block size. Ethereum has a current maximum block size, and in this proposal they double that block size arbitrarily, and then they take that current maximum size and they call that sort of like the optimal target block size. And so if you are producing blocks that are bigger than the target block size, then you say, okay, there's been an increase in demand. And if you're producing blocks that are smaller than target block size, you infer from that there's been a decrease in demand. And it's a proxy in the sense that those two aren't necessarily the same, but you take that as a predictor of demand. And the way you close that loop is, if there's an increase in demand, that tells me we should be raising price. And if there's a decrease in demand, that tells me we should be lowering price in order to generate more demand. And it does that over an average. So it adjusts the price up and down a little bit from each block based on whether or not it's deviating from the target block size. So that over the course of several blocks, if there's an extended period of increased demand, then you'll have an extended slow rise in price, which is going to try to suppress demand. And if you have, conversely, smaller blocks for a series of blocks, then it would infer there's been an extended period of decreased demand. So it would reduce the price and try to stimulate demand back up to that target block size.
Okay, so that's interesting. It's basically block size is built into the consensus, right? So everyone can actually see it and then agree upon it. And that's an indicator of demand. But
yeah, that's the main requirement for achieving consensus. It has to be something that everyone can observe. Yeah.
Yeah. So, having larger blocks, right? I think we talked about this quite a bit when we were investigating into the limitations of single chain topologies, right? And that's why we decided to go with the block DAG. So just increasing the block size alone, doesn't that have an impact on security?
Yeah. So increasing the block size in the absence of technical innovations or improvement in your network, bandwidth model and things like that does impact security in a single chain because it increases your forking rate. So that's like a very fundamental trade-off, and why very secure sort of like legacy blockchain networks or established blockchain networks like Bitcoin, for example, have a very low block generation rate because then you have a very low forking rate. And every time you fork, you increase the risk of a malicious attack in these kinds of networks, because the people that never fork are the people that are actually coordinated. Like the malicious attacking coordinated army is never going to fork on itself because it's conspiring with itself. The people that do fork are the honest, truly decentralized little guys out there making up the bulk of the network. And so to the extent that they start forking, it becomes really easy, or relatively easier, for a malicious player to produce a longer chain. And everything in engineering is a ratio. And so if I wait a minute, what's that relative to? If I wait 10 minutes, what's that relative to? Is that long or short? Well, it's relative to how long it takes to propagate a block. And so, the smaller the block, the more quickly you propagate that across the network. If it's like, if you had a 4 gigabyte DVD block that you had to download, it would take a long time to propagate that across the network, right? So they keep the block size relatively small compared to the amount of time they wait between blocks, so that there's very low risk of forking. And in a DAG, you get around that whole problem by inclusively taking all blocks and using the relationships between the blocks to generate a consensus over time on ordering, but not allowing a malicious player that doesn't fork to somehow have an extra weight compared to the honest players that do fork.
Right. Yeah. So Taraxa, I mean, that's actually exactly why we selected the block DAG topology, is because we don't have this problem, right? We don't have to just monotonically increase the block size, because we can simultaneously accept many blocks from many proposers, many block producers.
Yeah. So another way to look at our two-layer consensus model approach is that, you know, we can keep the DAG block sizes small, and we relatively small, so that they individually propagate fairly fast. And the effective block that we're producing at a given periodic interval is actually that block size times the number of DAG blocks that have been produced. And so without risking the consensus on the total number of, you know, DAG blocks produced, we can increase the amount of transactions packed into all those blocks and still execute more transactions, handle more capacity in a given unit of time.
Okay. So this actually raises another interesting question, right? So as a block producer, I, of course, would, you know, as any agent, rational economic agent, I would like to maximize the my profitability, right? So, for example, I mean, that's in Ethereum or Bitcoin. That's why block producers or miners, they stuff in, or they prioritize the transactions that are paying the highest fees, because they want to make the most. They want to make the most money, right? So there are all sorts of strategies on how you can actually, you know, make more money by, you know, doing a balance between block size and, you know, transaction fees and how much you stuff the block, etc., or even just produce an empty block in some scenarios. So I think it's very interesting that now we have this sort of a base fee and sort of like a tip kind of a mechanism that's being proposed here, and the mechanism through which everyone reaches consensus on network size, network congestion, which is block size. So block size is actually something that me as a block producer or miner, I can actually impact that, right? I mean, I can, you know, if a block size has some sort of flexibility between a range, and the larger the block size is an indication of more fees, I mean, I can just make the blocks really big, right? I can just make it as big as possible every single time. And then all the miners or producers on the network will get more fees, right? So, I mean, why wouldn't the blocks just be always at the maximum size, right? In this case, if the miners can just control it that way.
Yeah. So one of the key aspects of 1559, which, by the way, I think we should highlight, is coming to Ethereum, right? It's going to be adopted in the London update or whatever. And it does face pushback from miners within Ethereum, because one of the key aspects of this proposal that's actually, you know, relatively critical, is that the base fee part, the part that's determined by demand over time, doesn't actually go to the miner, right? That just gets burned. And therefore, what you're removing is the self-interest part of generating, you know, a big block when I'm the miner, because then I'm going to get all that money. Because it gets burned, I don't get it. And so you still have, it is true, the collective ability of miners taken as a whole to decide, okay, let's generate big blocks every time. But if they do that every time, they're not actually getting more money. They're just raising the base fee and depressing demand. And so eventually, you know, if you just allowed that to continue forever, you would get rid of all demand and there would be no transactions, period, right? So you drive yourself out of existence. Of course, it can be bounded, but essentially there's no incentive for them to get that base fee block size part wrong. And the goal is to, you know, in periods of no volatility, the total amount people are paying would basically be just that base fee, and the tip would diminish. In periods of like high volatility, yeah, people might start tipping, and then therefore it starts to look kind of revert back to the existing model. But by burning that base fee, you make this work economically, in the sense that you remove the self-interested aspect of the miner.
Yeah. So this is actually really interesting. I mean, when I first read about, you know, 1559, and, you know, I think the big news item that was being spread around, right, on social media, on, you know, crypto news, is that Ethereum is going to start burning fees, and it's a big news, right? Burning fees, because everyone thinks that if you're burning, you know, coins at any, you know, to any degree, that means you're effectively raising the value of the entire pool, right? So that was like the big marquee news item. But it seems like the fee burning part is not really meant to, it wasn't originally designed to actually raise the value of Ethereum, or it was actually designed to, make sure that this, this new mechanism that makes fees more predictable does not lead to malicious, self-interested behavior on the side of the block producers, the miners. So it wasn't actually intended to do that, right? It's actually pretty interesting. So I mean, you can think about there are actually other ways, right? I mean, even besides burning fees, like, I mean, just off the top of my head, maybe the fees doesn't have to go with the guy that produced the block. It maybe be given to some random guy who produced the next block or something, right? I mean, there are other ways where you can remove that self-interest.
Yeah, I mean, the essential part from the making the economics work for the pricing mechanism is that it doesn't go to the person producing the block. So, like you said, it could go into a future pool to be paid out to block producers in the future. It could even go to past block producers randomly or something like that. The easiest solution is just to burn it, right? Now, in a network like Ethereum, which relies on proof of work, in which miners are burning up huge amounts of electricity and destroying the environment and all that, they're very incentivized to be greedy and therefore very incentivized to be irate about this change. Now, on the other hand, you can ask, where are they going to go? But they have this big problem in Ethereum that is coming with this change, because this change is coming to Ethereum. If you think about adopting this kind of scheme within Taraxa, we don't have this problem, because the node runners are incentivized by being delegated to in our delegated proof of stake model, and in that sense, they take a cut, a fee off of that stake, and by burning coins, you increase everyone's stake value. So they're incentivized in a way that aligns with all the other people within the network, which is to increase the value of the underlying Taraxa token.
Okay. I mean, I think you already started to touch on this topic a little bit, which is, what can Taraxa learn from this, right? What parts of this I think we can actually look at. But I think in general, the having more predictable fees is obviously a good thing. I mean, I remember I was reading this article written by Vitalik. I don't remember where it was, but he was talking about how you get trade-offs, right? The first price auction system that's currently in Ethereum and Bitcoin makes fees very unpredictable, but it also is such a simple mechanism that it's very difficult to game, right? It's very, very hard to sort of game the system, and any sort of more complex systems are actually sort of easier to game. So that's why they chose it, and that's why I think we decided to sort of stick with it. But interestingly, I think this proposal does do quite a bit to address the predictability of fees. So I mean, what are some aspects that we can really adopt here for Taraxa that that would also make it make it better, and please highlight if what are some of the differences that we could potentially do versus what EIP 1559 is proposing for Ethereum.
Yeah. So one of the first things is Taraxa is intended to operate compatibly with Ethereum, right? So that we use the EVM, so we want to be able to port smart contracts over from Ethereum, and they run right away in Taraxa. We use the same cryptography with accounts. So the idea that a transaction would be specified in this way makes great sense, and the idea that you pay a predictable base fee plus a tip to cut the line is a great model. And it's definitely something we've talked about. To the extent that Taraxa drastically increases the capacity of the network, you might assume that in general we always have a lot of capacity and not as much demand. And so we've thought about that before, just like, what is the method for setting like a predictable fee, right, to charge, right, and one that appropriately incentivizes people to operate the network, stimulates demand, et cetera, et cetera. So I think the thing I like about this model is, well, first of all, if things get out of whack for whatever reason, right, you go through a period of really high demand, it basically reverts back to the simple fixed price auction. As people start, if everyone's including big tips, the base fee becomes less relevant. It looks just like first price auction, right? So it has that great sort of fallback behavior. And it incorporates a mechanism in which, in the converse situation, in which you have really predictable demand, the network produces a base fee. I think the thing that can be different in Taraxa is that, we have a whole PBFT layer on top of our DAG, for example. So, we could imagine other ways of injecting a proxy for demand, right? You don't necessarily have to look at block size or even like sort of like the cumulative aggregate block size and within a PBFT period. You could actually look at, what are the transactions like that are sitting in the mempool of my node when I propose a PBFT block, because, essentially most nodes should have a substantially similar mempool. And so, you could bound like the rate at which the mempool could change, and you could get a stable estimation of demand that way, in the same way they do sort of a low pass stable estimation of block size in this proposal 1559. So you could do something like that. I think that's the biggest thing. You could change what is the proxy for demand, but you definitely want to tie the fee into some sort of proxy for demand. And the burning part makes great sense too, because for the same reasons, even though we don't have miners and they're primarily in it for the reward and increasing the token value, if to the extent we have any block producers collecting fees, we don't want those to be selfishly, greedily mined, even if it's like a lesser consideration in our network.
Right. Yeah. So, I mean, taking away from this, maybe this is a feeding into what crypto investors and the crypto community are generally very interested in. What a key takeaway is that I think Taraxa is very keen on adopting many of the excellent proposals and ideas that are from EIP 1559, including burning transaction fees, or at least burning a baseline transaction fee. And since Taraxa has a much higher throughput seeding than Ethereum, we expect that the vast majority of time it would just be a base fee with no tip, right? So essentially, most of the time, Taraxa will be, the vast majority of the time, Taraxa will be burning all of its transaction fees. So that's actually very interesting. We're definitely going to put up on our updated roadmap, and so everyone can check it out. And I think it does do quite a bit to counterbalance the block reward inflation, right, which is also built into our protocol. And I think that's something that Ethereum also has an inflationary process as well. So it has a similar ancillary benefit to that effect. Okay, we're seeing quite a number of questions, so let's just go through and answer some of these questions. I think most of these are for you, Justin.
Okay, I don't know if I can see the questions. I should be looking, or else just make sure you read them off so I can.
I can read them off.
Okay, great.
It's in Q&A. I'm not sure if you can see that.
Oh, yeah.
Can you see that?
I think so.
Here,
Cool.
I'll just read them off. Can I run a Taraxa node yet? Yeah, I think that's a great question for Justin to answer.
Yeah. So not quite yet, or at least not with any incentivization. So we're just putting in the finishing touches this week on the infrastructure for people to be able to easily follow instructions that we've created to download and run a node, and then to register that node on the community site. And then having done that, we'll know the node exists. We can delegate to stake to that node, essentially play money, and then they can participate. And within the Explorer, we're going to tabulate everyone's contribution of blocks to the network and use that to dole out rewards to incentivize people to run nodes. So people that want to run nodes, that's awesome. And just stay tuned, because like very early next week, hopefully starting Monday, we'll be rolling out instructions and steps on how to do that, which is going to be super exciting, because I've run a lot of nodes. We've run a lot of nodes in internal testing, But it's definitely going to be a lot more fun to have other people running nodes too.
All right. So another question. You can read them, right? You can see them now, right?
Yeah.
Okay. Second question. Yeah.
So, hey, Justin, one question about the Taraxa chain is we know there are many projects that focus on layer one and have a rich ecosystem. For example, Polkadot, Solana, Conflux. What do you guys think about Taraxa will attract developers to build more dApps on your chain? What's the highlight of Taraxa? So, when Stephen and I have been thinking about blockchains and decentralization and the value of multiple chains and the value of individual chains, I think from a attractiveness standpoint, one of the main things that we've always thought is that a chain really thrives by sort of having like a core use case built into that chain or driving that chain, right? So, we built Taraxa to be the place to track informal agreements, informal transactions, data relationships from IoT, basically anchoring things into blockchain. So it's one of the reasons why we have the DAG, so it creates a wide funnel for getting things included in the chain really easily. And other chains are seeing this right now in the sense that Ethereum is a high barrier to get included in, right? Because it's for the very thing we've been talking about, you have to pay a big transaction fee, and the fee is not predictable, et cetera. So it's already creating spillover into other chains that you mentioned, for example, that are coming along, Polkadot, Solana, Conflux, and others. So, we have a core focus of the kind of applications we want to build and be optimized for on our chain, and that we hope people will come to our chain, both just to use the applications that we're building, but also the kind of other applications that we're going to basically invest in supporting and attracting to our chain. From a technological standpoint, I take sort of a different approach to thinking about it, which is, this is like very early days in the internet in my mind, kind of, right? And so, there's a lot of different projects out there taking a lot of different approaches, right? Sharding, side chains, bridges, like the hub and spoke model, for how to interoperate between chains and across chains. And different chains have different technological approaches. They make different security assumptions. Pretty much every chain that's coming along is going to have including Ethereum 2.0, is going to have more throughput than Ethereum 1.0. So a lot of the incentivization for developing all these different technologies is really to create diversity of technology and to explore the space. And over time, certain ideas will mature and win out, but also certain ideas will be uniquely tailored to individual projects. So we've certainly made things for our chain that are tailored to the idea of anchoring, as I already mentioned. So for us, it's important to have the competency and the skill, but also to be able to control our own fate, right? If we just wanted to build the applications, we're motivated by the applications. But if we just build the application, then we're dependent on this very infantile, unmature technology that is layer one blockchain, right? So we want to be there controlling our own future and really optimizing it for our applications.
Okay, great. I think there are two more questions. Let's see. How will we build on top of Taraxa network? Here, I'll take this on. So, actually right now, after we release the incentivized testnet, you can actually go into our sandbox application, which is at the top of our documentation, and you can actually just deploy a smart contract into it. Now, when we first started Taraxa, Justin and I, we made a very conscious decision to actually make sure that every aspect of Taraxa, although the architecture underneath is completely different than Ethereum, but we wanted to make sure that all the RPC calls and all the way that the outside world would interface with the blockchain, the Taraxa blockchain, would be the same as with Ethereum. And the reason why we made that decision is because there's so much tools right out there already made for Ethereum. There's wallets and applications and lots of interesting user interfaces, and so not to mention the tens of thousands of applications are already deployed on Ethereum. So what we actually wanted to do was to make sure that if you can deploy something onto Ethereum, you can do the exact same thing in the exact same way that you would do it onto Taraxa, just so that we make everyone's lives easier. So we actually didn't really spend a ton of time documenting it because it's the same way that you would do it on Ethereum. So the sandbox application is a test application. It's very, very rough around the edges. We haven't had gotten around to put a lot of time into it yet. But there is there is a section out there where you can deploy smart contracts. So go check it out if you're a developer. Just once again, the interface looks very unpolished right now. So
yeah, so absolutely, people are going to be able to build on top of our network. We want the process for this to be, if you can build on Ethereum, you can build on our network without really any much added knowledge. I think there's a few areas in which we're going to be able to, with added knowledge, make apps even more efficient, right? And the last part about it, if there's documentation, we're lagging behind on that, I would say. A lot of that documentation that's out there for Ethereum will apply to us, of course. And also, as we incentivize the test net and incentivize people to build on our network, we're going to rely on the community to sort of help us find areas in which we, maybe have failed to achieve complete compatibility. We've already, internally, we've found some, squashed them, got rid of them, but we haven't spent all day, every day on, doing the things that people that are deploying apps will be doing themselves. So, we're going to benefit with working with the community on that.
Okay, cool. So two last questions. What does the Helio application do? The Helio application, we said before, Taraxa's goal is to really make a lot of informal transactional agreements and data very, very trusted, right? I mean, that's what we're trying to do, because the world today is moving so quickly and generating such a massive amount of data set that as projects get bigger, as organizations get bigger, they actually get less data, right? That's actually very paradoxical, and they cannot make informed decisions quickly and react very quickly to market changes, and therefore they're not as innovative, right? So this is why large organizations and larger projects inevitably go down this road of decline because of that. It's not really anyone's fault. That's just the way the world works, right? So what Helio does is that it addresses that problem for machines, right? How can we make machine-generated data much more trustworthy? How can we generate consensus within stakeholders, between stakeholders? Essentially, what we are doing is that we have actually created a hardware endpoint. It's a secure hardware endpoint that can be integrated into various hardware assets that captures signals from within these assets from the source site and actually anchors that into an audit trail onto the Taraxa blockchain. So that's essentially what Helio does. By doing that, it guarantees that we can perfectly trace the provenance where the data is coming from, so it came from a specific piece of equipment. And then we can also guarantee that after the data was generated, it wasn't tampered with. So then you can start driving consensus among stakeholders that, hey, this data is real, it's trustworthy. So we can actually make business agreements based on top of this data. Consequently, if you're able to trust machine-generated data, that piece of machine just became a lot more useful, right? So that's essentially what Helio does. Justin, you have anything to add to that?
Yeah, I mean, I would just say, like, what really excites me about this use case is it's a great example of where blockchain doesn't really replace an existing technology. It just or existing operation. It just adds a layer on top of that enables sort of new business models. So, if you imagine any kind of use case, and it turns out there's tons of these, where the person holding the device or where the device is installed, the operator, the custodian of the device, whatever, doesn't really know the first thing about the device's internal workings or anything like that. But they're in some sort of business agreement with the renter, the loaner, or the fielder of the device, the creator of the device, right? Then this enables that, because you can anchor the data and everyone can see the data to the extent that they need to, and they can get rid of the confusion about sort of what's really going on. Is this data valid? What was happening when? If you only check in monthly with a, usage total to pay your fee or to share out rewards, So any kind of equipment rental or any kind of equipment monitoring or supply chain monitoring or anything like that, it sort of solves the confusion and the trust gaps. And so it turns out there's a lot of businesses where, they operate with some element of confusion and uncertainty, but as long as everyone's making money, they're happy. But they're very afraid to expand that operation to people they don't know, don't have a history with, because things could go very wrong. If they don't make money, they don't know whose fault it is, and then they get into disputes. So this really solves a lot of those trust gaps and enables people to expand their businesses and business opportunities. And I think that's really exciting.
Cool. Last question. Any Taraxa apps the community can experience? Yeah, so I mean, we're doing actually a rewrite of our Marinate app, and I think one of the integrations that we're going to be pushing out is a Telegram integration, right? So
yeah, it's gonna be cool.
Yeah, it's going to be very cool, and we're going to have some interesting crypto relevant use cases, and I know, right, this has been a criticism in the past from the community that all of our use cases are sort of in in businesses, right, in like asset leasing, in automotive, in construction, and they most people don't understand them if you're not in that industry. So we are a crypto project, therefore I think it behooves us to really generate use cases that our community, our core community, can understand and actually participating. So yeah, so that's definitely coming, and we're very excited about the rollout.
Yeah, I mean, I think we're a little bit guilty of having targeted, like the total addressable market of the non-crypto world is huge, and that's sort of our niche bread and butter that we spent a lot of time working on applications that address like off-chain market. The pitfall of that is that no one is more reliable at producing adoption and driving the project forward than the crypto community themselves, right? So we need to address that market too. So that's why we're very excited about the Telegram integration, in part.
Exactly.
It's going to be very cool.
Cool. All right. So that's the last question. And yeah, this ends our weekly AMA. Thank you, everyone, for tuning in. Thank you, Justin, for participating. Hopefully,
yeah, it's great.
We'll see a lot more of you.
All right. Cool.
All right. Okay. Bye, everyone.
Take care.